In this video, we're going to continue our work in sections 13.3 and 13.4. We're going to now look at the cross product. And to start, we're going to look at the algebraic definition of the cross product, meaning this is how we compute a cross product. So similar to in our previous example, when we looked at dot products, we're going to start with two vectors, v and w. Then the cross product, written as v cross w, of v and w is defined as follows. So I'm not going to read all that out. Notice all of these computations we're going to make. So for each I, j, and k, we're going to use the components from v and w in a certain way. Now this formula is rather involved, or rather not involved, but there are a lot of computations. There's a lot of products, a lot of subtraction you have to take. And so it's a difficult one to memorize. So what we're going to do is go through a procedure of how to come up with this formula in a step-by-step approach that's going to help us remember how to make the computations. All right, but before we look at that, I just want us to reflect on what this cross product is. Notice that we still have an I, a j, and a k vector in this product. So what we get in the end is a vector back. So this is a vector quantity. So as we're in the dot product, we got a scalar when we took the dot product of two vectors. For a cross product, we get a vector when we take the cross product. All right, so now we're going to look at how the calculation of the cross product works out. And so in order to do this, we're going to compute something called a determinate. So if you're interested in engineering or computer science, you're going to use and see determinants quite a bit. You might have even calculated them in a previous maybe physics class or another course. So if you haven't seen this before, it might be a good idea to rewatch this video a couple of times so you get the process down. All right, so let's get started. So to compute the cross product between v and w, we're going to write out the following matrix or array. So what I'm going to do is start with my I, j, and k. And then I'm going to list out the components of v, so v1, v2, v3, and then the components of w, w1, w2, w3. And then some notation here, I'm going to put in these two brackets. That tells us that we're taking a determinant. So it's notation for take a determinant of this collection. Okay, so now in Volve 2, we also have some signs on our columns. So plus, minus, and plus. And the operations we do here actually generalize for bigger arrays of numbers, which you might see at some point in your life. In our class, we're going to be sticking to at most three-dimensional vectors. Okay, so let's compute this determinant. So how do we do it? So here is the approach. So what we do is we start with the first row and column and we cross them out. And the object in that first row and column, I, goes first. So we're going to write I. So this is the I component we're using. And this I has a plus attached to it. So we'll just have plus I. And now we're going to make the following computation with what remains. So notice left in our array of numbers is V2, V3, W2, W3. So now what we're going to do is multiply the diagonals, V2, W3, and write that next, V2, W3, then subtract the product of the other diagonals. So then I'm going to subtract V3, W2. Okay, so that is how I take care of the first row and column. So now I'm going to start again. I'm going to clean this up a little bit, just rewrite my numbers here so we don't get too cluttered. So we have our I, j, k. Have our V1, V2, V3, W1, W2, W3. Okay, so now we're going to take care of the next column and first row. So we cross out those two. So now what we're dealing with is negative. Notice there's a negative symbol up here, negative j. So I'm going to write now negative j. And I'm going to do the same thing with those box of four numbers that remain. meaning I'm going to take the diagonal V1 times W3. So V1 times W3. Subtract the opposite diagonal. So subtract V3 W1. And now I've taken care of that next column. So then finally, I just need to take care of the third column. So what that looks like is the following: IJK, V1, V2, V3, W1, W2, W3. So I'm going to cross out that final column and my row. So that's our K component. And I'm adding. So now I'm going to add K times, and now I'm looking at this sub collection or sub matrix. I'm going to look at the diagonals. So V1, W2, multiply those together. V1, W2, and then subtract the product of the other diagonals, V2, W1. All right, so there is our determinant. So notice what happens when we move things around a bit, like put the I's, J's, and K's at the end, and then also bring in that negative symbol here. Let's carry that operation out. So what we'd start with is V2 rather, W3 minus V3 W2 times I plus negative V1 W3 plus V3 W1. So I could even rewrite those or switch the ordering. So start with my positive number. So I get positive V3 W1 minus V1 W3 plus V1 W2 minus V2 W1 times K. So notice how this compares with the formula that we have up here for the cross product. Similarities? Well, you'll notice that we get the same computations, V2 W3 minus V3 W2. And you can check each component, V3 W1, V1 W3, V1 W2, minus V2 W1. So that is how we can remember how to take a cross product of two vectors. So again, I really highly encourage you to rewatch this video a couple times so you get the process down. Again, it's a little bit involved, but once you do it a couple times, once you see the examples, you'll start to feel a lot more comfortable with it. All right, thanks for watching.